guys to focus on me and what I'm doing, and then I can stop if you need to, so you can take your notes. But I really need to chunk this down and let you dissect this. What we're doing today is this thing called partial fraction decomposition. It sounds really cool, doesn't it? No? You said no. It sounds like it's going to be hard. A little bit. So I'll go slow. If I start going fast, please tell me when you'll slow down. You're getting excited. And I am rusty on this too, so I need you to really be diligent and check my work, okay? So, you guys ready? So, partial fraction decomposition. We'll be trying to take a look at all these. When you got linear factors, repeated linear factors, non-repeating primes. We might just make it to the first two. Maybe we make it the other two. We'll go as far as we can, okay? If it takes us another day, then we'll do it another day on Monday when we come back. But this is why I definitely didn't want to do it Friday. It would have just been like, what? All right. So, yeah, these are our objectives. They're not even words. But we're going to decompose some of these fractions, okay? And just to make the idea clear to you, let's do this real quick. Do you guys remember how we used to have rational expressions that we would just add and subtract kind of thing? So I'd have something like maybe, I don't know, p over x squared minus 4 plus 2p plus 3 over x squared minus 3x plus 4. Remember we used to have that kind of problems? And then we used to put them all into one fraction?
Yeah.
What we're doing is we're going to reverse.
Oh, great. That'll be fun.
Does that make sense?
Yeah.
So we're going to start with that, and we're going to have to figure out what the original fractions were.
Oh, so it's kind of like the one where we were, or like how you had the logs and stuff like that, and you had the x. You know what I'm talking about? And you had to put them together and you had to take them apart.
Kind of. Yeah, I know what you're talking about. Okay.
I kind of feel like
Yeah, no, nothing like that.
I like that.
The logarithms are very different because there's specific rules when you see the addition subtraction type thing.
Right.
But yeah, we're going back to what it originally was. So here we have this, and we're going to be moving. We're going to try to figure out what the original fractions were there. Does that make sense? So here's what we're going to do. Let's start with our what we had at the beginning here. Or sorry, not the beginning, but at the end. We ended up with this business. Okay? And I'm going to set this equal to what should have been the most basic fractions to begin with, right? So if you look at the denominator, let me try to scoot this over a little bit. If I look at the denominator, there was two denominators there, right? And of course, if you think about it, the easiest way is to multiply the two. So if you think about this, if this was just numbers and I had a fraction with a denominator of 12, then it probably came from doing like a 3 with a 4, right? 3 times 4 will give you my 12 denominator business, or maybe a 2 and a 6 type thing. Does that make sense? So that's the same idea that we're going to do here. Luckily for us, we don't have that many options. All we know is that one denominator could have been x minus 3, and the other denominator could have been x plus 4. Does that make sense?
Is there any other possibility?
No, because the way to get this denominator would be this times that. You see how that works?
Yeah.
Now for the other ones, yeah, there'll be other possibilities, and we'll have to count for them. But for now, for this problem, those are my only two options, aren't there?
Yeah.
Now, do I really know what goes up top? I don't. So I'm just going to call this numerator A and numerator B. Cool?
Yeah.
Now I know that I've set this up as a true statement. These two fractions should add up to give me this big rational whatever. And I'm going to start just doing some algebra, huh? I want to get rid of this denominator. That means I would have to multiply by x minus 3 and x plus 4, correct?
Yeah.
But what's the magic rule say? What I do to one side, I've got to do to the other side. So I'm going to multiply this by x minus 3 and x plus 4. Okay? So this will make a 1. And I'm throwing air quotes there for my cancel. That will leave me with 5x minus 1, correct? Now as I distribute the other part, I'm going to, the x minus 3's will cancel, won't they?
Yes.
So we'll end up with a times x plus 4.
Yeah.
And I will end up with plus b times
X minus 3.
x minus 3. Okay? Give you guys a little bit to process that.
Oh, so we're just doing the backwards step. How? Oh, okay.
We good here so far? Okay. All right. Let's continue then.
Oh wait, can I finish the couple?
Oh, for sure. You trying to shake money out of that or something?
Yeah.
My car stereo. It wasn't working very well. It only had radio now. So I replaced it. But when I took it out, it jiggled. So I started shaking it out. About $2.50 fell out of it. Quarters, nickels, pennies, everything.
Damn.
Can't just throw, coins in there. From the dash, you have coins there all the time? Yeah. Ugh, I don't like that. Okay. So, here's what I've got on the next step. I'm going to clean that up. All right, bud. Did I distribute that correctly? Someone double check, please.
Yeah, you did.
We're good? All right, I'm going to group all the x stuff together over here. So that means ax and bx, right? And then I would have something that doesn't have an x. So plus 4a minus 3b. Is that correct there?
Yes.
Okay. Now, if I look at this first one here, they both have an x in common, don't they? So I would have, I could do this. I could say a plus b times x, couldn't I? And then, well, the other part would just kind of remain. It would be 4a minus 3b, and there's no x, right? And all of that equals 5x minus 1. Does that make sense so far?
Yes.
Okay, now let's do some logic thinking here. A plus b is just a number, isn't it? Okay, and if I'm saying these two things are equal, then what does a plus b equal?
What? A plus B? 5x.
Well, hold on. Now remember, this is a binomial, correct? On this side, I've got a first degree and I have a 0 degree term, correct? So let's look at the first degree term. Okay, what's the coefficient on x to the first degree?
5.
What's it here on the right side? This is a plus b, right? And I'm saying that it equals the left side. So what does a plus b? What should a plus b equal?
5.
Someone said it. Yeah, a plus b. So a plus b should equal 5. Now over on this side, there is no x, right? But that's because x is to the 0 degree, and so it is also here, correct? So what does 4a minus 3b equal?
Oh, A is 1. Oh, wait.
Negative 1. Right? Questions on that from anyone?
A is 1 and B.
So all I did was set it up so that they look similar, and I said, oh, these are the coefficients, and if they're the same, then the coefficients should match the other coefficients. You guys see the logic behind that? Okay. Well, yeah, it is a rule. Here, think about this real quick. If I told you that 5x equaled bx, what does b equal? 5. I use that logic. That's the same logic that I just used. Huh? This is not cheating. Matt don't like hard. Matt don't like hard. Sorry.
Okay, I have to be confident.
All right. I'll pause here for a bit because that's the hard part. That's the hard part. Yeah. Right, that's the question, isn't it? Because we want partial fraction decomposition, so we got to go back to the top, plug in A, plug in B, don't we?
Wait. So if we know that if a plus b equals 5, then 4a minus b equals -1, like we can just plug in like kind of like 2, 3, for like because it's such round, right? We can do that.
All right, so let me so
We get to change.
so now if these equations only had one variable, I would be able to solve them, right? But they don't. They have. Don't listen and okay. I will pause. I will
A is
just
2.
enjoy a few swigs of my cafe.
A
You good, Sonny Lil? Guys, keep your noise down, please. Little professional courtesy for your neighbors here. Right, Hannah? Nice boots, by the way. I like those.
I feel like this is gonna get a lot more complicated.
No, at this point, it's a piece of cake.
No, like later on.
Oh,
You
yes.
have, like, a lot and
We
it's
figured it out.
Well, if you think about this, you can have
So
quadratics, right? Nonlinear factors. So, we'll get to those. I just want to make sure we're getting this little by little. And everyone's okay so far? All right, so here's the deal.
now,
Here's the deal. I can't solve this red equation because it's two variables. I can't solve that equation because it's two variables. But, remember I said if I did have two variables, how many equations would I need? Two. And I do. I've got a plus b equals 5. 4a minus 3b equals -1. What have I just created?
that makes sense.
Oh, nice. Now I've got a system I can solve. So, I'm going to multiply the top equation by -4. That will give me -4a minus 4b equals -20. So then I've got -7b equals -21. So b equals 3.
Yeah, I figured it out.
And what does a equal? 2. Yes? The 4a minus 3b equals -1 from right here. Okay, so remember what I said about this? 5x equals bx. What does b equal? Okay, so let's go here. Let's go here. I'm saying that this piece of the equation is the same as this piece of the equation, right? So that means that 4a minus 3b should be the same as the -1. So 4a minus 3b is equal to -1. Just like over here on this side, the a plus b should equal the 5. What's your class next?
I could just turn it in and study more.
It's up to you, or take it with you and try to teach it over there, but you got 60 minutes.
nope, I don't know.
Say, hey, I'm here, but I need to finish my classes out
So
of
what's
here.
B and A?
Okay, that's what we're getting to.
Oh.
So what we did, Sonny, is we took those two equations we came up with, and we solved the system.
Oh yeah.
And we found that b was 3, and if b is 3 according to this equation, then a has to be...
Yeah, but like what? Like are they like coordinates? Or
No. Well, remember at the beginning what we did? Oh, look at that. So it goes here, and b goes there.
So we have a whole other part to do now.
No, we're done. So that means, what was the a? 2,
You was 3.
and b is
3.
3. So what we're saying is, these two were the original fractions that got added to make that.
Makes sense. Use that hard, it's just a long process. It doesn't look hard until big though, because it's just like a really long process.
Little logic there, huh?
Yeah, it's really long.
Excuse me. Okay. You guys good over there? Burger, burger.
Why are you Monday?
I'm not.
Me neither. Reality, me neither.
Reality says it.
Reality hits you.
I'm not, bro. I'm not, bro. I really need a hug.
Not so bad?
No, actually I like it. It's not that hard.
Actually, I like it. All right.
I like math. Leave me alone.
Here's our next problem. Now notice, this does not have linear factors. It has one linear factor and one, oh, touche, one non. Thanks for that compliment. One quadratic, okay? So, we're going to take someone tell me what fractions I should have. Let's start with a over what? A over x, and then b over x minus 1. Do we need any more?
Yeah, because we have to have x plus 1. We had a c.
Not x minus 1. It's already there.
X plus 1. Or is it x?
Where's the x plus 1s?
No, it's
Because
the
x minus. Oh wait, no.
X minus one.
We already have it.
But it's
No,
there.
it's not the X minus one
But why would I repeat it if it's already there?
I don't know.
Oh, could you square the b?
Or why don't you just put X minus one squared?
Yes. There's a possibility that one of them had both of them. Right?
What?
Think about this. If I'm looking think about this. Think about this for a second. If I have in the denominator, it could have been that this wasn't even there at all to begin with, was it?
Oh, okay.
Right?
Okay.
But there's a possibility that there was, but I didn't need to write it because this denominator here, oops, would have taken care of it. So I need to make sure that I account for both scenarios.
Should we have to do two? I don't get it.
Yeah, there's a possibility I could have both situations. You don't get it?
Why is there a middle one? I don't get it either. If it's not needed, then why is it?
Okay.
Then why do we need the middle one then?
Yeah, you just
We can just use the one that's, yeah.
Let's do this, okay? I don't know. I just made something up. Whatever. Let's stop and think about the breakdown of this. Okay. Let's look at what could I have as far as the denominator here. I could do what? I could do a 6 and a 3. Sorry, but this 6, couldn't that 6 have been a 2 and a 3?
Okay, that makes sense, but like one at the top.
Sorry, not 2 and a 3. A 2 times 3, right? So, if I'm looking for a common denominator in this scenario, do I need both 3s there? Do I have to show this one?
No.
Well, I would show it once, right? But do I show it again for this one? No.
But if you squared it on that side, why would you need it? Wouldn't there be like an extra 3? Because you know, see how it's squared on that side?
See, that would
Right.
that make it.
So, what if it was,
That would make it 3 3s.
let's do this.
Like that.
Let's do this then. Let's try this real quick. Let's say I had, let's see if I can try to explain some reverse. Let's say I had a fraction that was a ninth plus a third plus a half. Okay? Let's think about it this way. What would my common denominator be?
18.
Oh, that's kind of what I was trying to go with the other one. So this would be 18, right? Right? Why is it not 50 something? What would it be?
It'd be like,
What's 18 times 3?
shoot.
Oh, okay.
54?
What's 18 times 3?
Hold on. You can't do math.
56?
54.
54? Why is this not 54? Because 3 is a factor of 9. Right? You see the scenario? So it's possible. You don't understand that?
I don't either.
No, it doesn't make any sense at the top that you need to multiply X minus 1 times X minus 1.
What I'm saying right now, let's ignore the original problem for now, okay? Let's look at this fraction from second grade. Third, fourth, wherever. I'm trying to find the LCD, correct? And it turns out that it's 18. Right? Process that for a second. Because 2 doesn't go into 9, right? So we're okay with 18?
Yeah.
The question though is, why is it not 54? Because 9 times 3 times 2 would be 54, right?
Yeah.
So why is it 18 and not 54?
LCD, lowest like.
But the way we get them is by multiplying them, right? So why didn't we do 9 times 3 times 2?
By each other then.
We do that because this is already a factor of 9, isn't it? 3 squared. So you see how there's a 3 squared?
Yeah.
and a 3 to the first power. But I don't need to show this one because it's already represented by 3 squared, correct?
So,
Oh.
Right?
that's not represented.
So,
Not represented only because you have 9, which is
So,
3.
my question is, why is there the bx minus 1? So, would you take off the 1/3?
think about, no, because think about this. If I want to go backwards and look at all the pieces, there could have been a 3 and there could have been a 3 squared, right? So this is 3 and this is like 3 squared. I gotta make sure I show all pieces.
So did you just put like 2 different scenarios
Yeah,
in the same?
because I want to make sure I count for all of them. Now, it could turn out that B is 0 and that piece wasn't there. Does that make sense?
So, wouldn't it be 2 different scenarios then?
Well, yeah, they're 2 different scenarios, but he's putting them in
Right,
one.
so what we need to do is account for all of them. So these are all the scenarios that could happen. That's the maximum number of pieces.
Can you show it
So if your B ends up
Hold
not
on.
being there, doesn't
if
matter.
Go
it
ahead.
was to the 3rd power instead? Can you show that one?
If B was to the 3rd power, okay, so if this guy was to the 3rd power, then you should have X, you should have an, sorry, these should be all denominators, right? Then you should have an X minus 1, you should have a X minus 1 to the 2nd, and you should have an X minus 1 to the 3rd.
So basically, if one of them has a power, then you have to go like back one. So
You have to go all of them, right?
if it was like the 5, then it'd be an X minus 1.
To the 1st, X minus 1 to the 2nd, X minus 1 to the 3rd, X minus 1 to the 4th.
So it's just like a wolf kind of.
Yeah, because it could have been that one was a factor of the other, and I want to make sure that I account for it.
Okay.
Okay? It's kind of like when you take the square root of a square. It could have been the plus or the minus. I want to make sure I account for both of them. What's up?
What if instead of that, it was the x by itself that was like squared or something?
Then you would have an x and an x squared.
Okay, nice. So if you had like a x minus 1 squared, and then you had the x minus 1 to the 3rd. Never mind. I don't want to.
So the question was, what if I had an x squared with an x minus 1?
Yeah.
Then I would have,
That one's.
one would be an x, another would be x squared, and then I would have x minus 1.
And then if the x minus 1 was squared, you'd have x minus 1 and then x.
And then I would have a fourth one, correct? All right, cool. So are we good with that? Any more questions on this piece? Why I broke it up that way?
It hurt my head a little bit.
It does. That's why I said, we'll take what time we need so we can discuss it and talk about it. Maya, you good? Did your brain just blow up? Any more questions here before we carry on? Yeah, read. All right. What are we doing at this point? Same as before. We're going to try to get rid of this denominator. We're going to multiply both sides by x minus 1 quantity squared. So all of this will get multiplied by x times x minus 1 squared. So I've got x plus 2 is equal to a times x minus 1 squared, correct? Plus b times x times x minus 1. And finally, plus c times x.
Okay, hold on.
So,
Okay, yeah, I see that. Oh, so you took the square root? Okay. X minus.
Yeah, Where?
I got it.
Where are we confusion?
Because you have, it's x minus 1 because you're taking away one of the x minus 1s, but you still have the x because you have the x there. So
Yeah, so if this is getting FOILed out to everything, then this would be multiplied, this b would be multiplied by x times x minus 1 squared, right? So one of them would cancel, leaving with b x minus 1. Right? Because I'm doing it to all of those 3 terms. Do you guys see why I wanted not to do it on a Friday?
yeah, I agree.
Y'all would have tapped out already. Like, no, I'm done. The weekend's here.
I'm tapping it right now.
Yeah, I'm tapping out since last week.
So are we
Are we good so far? Are we good so far? Go ahead.
For the C part, wouldn't you just be able to get rid of the x minus 1 squared? How
Right, and that's why I only have the c left, or the x left. So if I multiply this by x times x minus 1 quantity squared, then yes, these become 1, and I'm left with cx.
And what about the x minus one?
They're gone. It's cx minus 1 squared over cx minus 1 squared.
But wouldn't you only be able to get rid of
No, you only
two
get one.
x minus one, so not three?
Right, there's not 3 of
We
them.
only have two of them.
There are only 2.
But wouldn't you know one times
I'm not gonna foil it out, no. Not at that, not yet. Okay? Alright, we good? Any more questions here? That's a lot to digest. Alright, I'm gonna clean this up now. So I've got x plus 2 equals a times, you know what, I'm gonna change the color so you can see the only thing that I'm changing right now. I'm gonna FOIL this out. So that's gonna give me x squared minus 2x plus 1 plus bx squared minus bx
Yeah. Plus C.
plus cx. That's horrible x, but
What the hell's happening?
Why
What
did-
is it now?
Why did you?
I'll use my green. This got foiled.
Okay, so that one got foiled and the other one got
I only foiled this piece of it. Okay? Did that help?
yeah, let me skirt it down a bit.
Right? Now we wait. Should I go to the next step? All right, cool. So here we go. I'm going to just FOIL out. I think that's all I can do really is FOIL out the red part. So I've got x plus 2 is equal to ax squared minus 2ax plus a plus bx squared minus bx plus c. Right? cx, thank you. Woo. All right, we're good? I think so at this point. Okay. I'm going to regroup. I'm going to start by putting all my x squared values at the front. So I've got ax squared plus bx squared. All of my first degree values at the front. So minus 2ax minus bx plus cx, and then finally plus a. It's so lonely. What's up? We're okay there? Not very much, right?
I changed my mind. I don't like it.
I'm gonna rewrite the red part as
X squared times
a plus b
times
x squared. Right? And then the green part will become minus.
I mean, you could.
Let's do
combine
plus
it.
the quantity
Negative 2a.
negative 2a minus b
And C.
plus c times x. That's why I said double check my work here, guys. This is good?
Yeah.
And then finally plus a?
Yeah. I was like, what happened to the A?
Okay.
I know, right? It's like we got it in trig and you weren't my friend anymore.
Okay, we're here.
I mean, the beginning part of trig, yeah.
Wait, sorry. Oh, wait, wait, okay. Let me like try to figure this out.
It's like I've been with for years and now I don't know you
So is the
anymore.
red gonna be equal to 0 and the green gonna be equal to
Yes!
Okay.
What? I did not hear any of that.
So a plus b is going to end up equaling 0 because there's no square value. Negative 2a minus b plus c is going to equal
D.
Yeah.
1. Because that's the coefficient, right? The coefficient on x.
Oh.
That means that a equals 2.
Get it!
And now I just solved my system again.
I mean, yeah, because you have. Okay, I get it. I get it. I get it. So we have.
It's a little.
-2. It's just a little tedious. That's all.
A little bit.
A little is understatement.
Huh? Because that's the constant, right? See how there's no x's there? So what does the constant equal over here? Yeah, see, if I added the other piece over here, this would be 0x squares, right? So the x squares, a plus b, will be equal 0. The green part, the coefficient is a 1, and then a is just 2.
Oh.
That's a good, sorry,
Technically, we still have
blue.
Drew equation.
A equals 2.
Now opposite of.
Someone says negative 2 because if you plug it in here, if they make 0, then one has to be the opposite, right? And you can just plug them all into the green one. Yeah, so I believe that A is 2,
Wow.
B is negative 2, and then I can use the green one for...
C is 3. Wait, what? By the way, B is negative 2, not 2.
Did I put it backwards?
Oh no, no, I put it in the wrong. Sorry, I was looking at a different column.
Right?
Yeah.
So this is negative, and that's positive. So C equals 1? No, it doesn't.
No.
Because this is negative 4 plus 2 plus C equals 1. So that's going to be, so plus 2 plus 2. So C is equal to 3.
C is 3.
And there's your, then take them to the back, put them on A, B, and C. Partial fraction decomposition.
I don't like it.
This is the first lesson that everyone was like, "Darn." You would get a 0. So 0 over anything is 0, right? So it would go away.
Yeah. Yeah, because look at when you add, if you subtract 2, you get negative 4 plus C is equal to negative 1. Add 4, C is equal to 3.
No, because A, B, and C are all integers.
Yeah, because
Less than or greater than 0.
subtract the 2.
If there was a 0 there, if one of those letters were 0,
No.
then that whole fraction piece would just go away.
Oh, yeah.
Right? Because what's 0 over anything?
Negative had to add that.
Yeah. All right.
I get it, I just don't like it. Math doesn't like me.
Well, you know what? Don't feel bad. Those of you guys are taking calculus,
Me, I'll take it next year.
when you start doing, I think it's you do the derivatives and then you do the integrals. So integrals is going backwards. So yeah, so
Can you teach calc? Please? Please?
I cannot.
Why? I'm gonna die in
How are we doing? We got time for one more? All right, let's just do this then. How about we do it as a class? You guys watch me and make sure that your processes are correct. Okay? Because this one is a
Wait a second. What the? I want to do this one. It looks interesting-ish.
well. We'll be doing it together because like I said, I'm really rusty. It's been a while. So, but we'll take the same ideas, right?
Is there like a shortcut?
No.
I'm scared for this, Genevieve.
Look at all the
Try graphing those. Sorry. Let's see. Is this even factorable?
Yeah, that's 2 and 1. Or wait, negative 2. Wait.
Nope.
Yeah, it is. It's because you have x.
Multiplies to this adds up to this. You'd have to multiply. You'd have to be a 2 and a 1.
Yeah.
What do we need to factor in?
So it looks like that's a prime. Let's double check it. B squared minus 4 times A times C. That's a 1. That's a 1. That's a 2. So we got 1. Nope, not factorable. That would be way bigger than this.
Yeah.
So, not too bad.
Is that the only way you can solve for x math? Like, for that problem?
On the
That's the only way you can solve for x.
like 1,000 slides on this last one.
But you only have 2D
Alrighty. Oh, I missed a slide, didn't I? Okay, this one. Take a look at this piece. Partial fraction decomposition. I didn't show you the other ones because they make a lot more sense than this one does. So if you have a quadratic, has not repeated prime, has a non-repeated prime quadratic factor. If ax squared plus bx plus c is prime, then the partial fraction decomposition will take on this form. What? No, I want to give you this rule first because we needed to do this problem. Okay? Here's what the rule says. If you have a prime quadratic, which is what this is, we just checked it, right? That's a prime quadratic. That means that its partial fraction decomposition must take on the form of ax plus b. The numerator has to be linear. Okay? What does that mean for us? Well, that means for us that when we're doing this problem here, all of that, let me see if I can, our 2 will look like this. We'll have a over x plus 3 plus x squared plus x plus 2. It must be linear, right?
Yeah.
So we already got a, which means bx plus c. To the rule? They're just giving you the rule here because if you notice, where'd it go? Notice how this one is linear, so the top one is constant. Right, unless it's like a perfect square where it was squared. The binomial was linear, right? So the numerator is going to be constant. What's up? Back to here. I skipped a few slides, so let me go back to those, okay? Okay. Yeah, so these are linear. The top ones are constants. This one I skipped, yeah. So you got linears. Let's see, the form partial rational expressions with distinct linear factors in the denominator. So if you have linears, your tops will be constants. Here's the next one. These are still linear, even though they're kind of squared and cubed. We were able to express them as linear, so the numerators would be constants as well.
That's the thing, like, you should have said, how you said, like, how is the n squared and multiplied? No, you see what I'm saying? Has the regular power over and over.
Yeah, so it doesn't matter if it repeats, it's still a linear factor, right? So you're going to have constants in the numerator. Let's get this other slide. So here's this one. This says the form of a partial fraction decomposition for a rational expression containing prime factors, ax squared plus bx plus c, recurring n number of times as its denominator, still going to be linear on top. So you got quadratics. Even though they're squared or cubed, you're still going to get linears up top. So I guess that kind of rule does fit. Okay. Okay, can we get back to here? You guys done taking pictures? Okay.
Wait, one momento.
Core flavor? Okay. Now, can you guys kind of already see what's going to happen here? Can I skip all that step of rewriting everything? Míralo! See you later, Ricky Martin. Catherine. Can you pass that back to Catherine? Okay. So we should end up with 8x squared plus 12x minus 20 is equal to a times x squared plus x plus 2 plus bx plus c times x plus 3, correct? That's what we get at the end? Bye, be safe. That's what's going to end up happening, right?
Let me just copy it now.
And it should be this times this. Don't forget your
Oh yeah, that's true.
right?
Did you like CrossFit?
Pretty much. Pretty much.
Why?
Well, here, think about this. This side is equal to 8x squared plus 12x.
Oh wait, so did you like?
I already did all these steps.
Yeah, just like in your head.
Yeah. So all of this would have to get multiplied by this x plus 3
Oh, okay. Okay.
x squared plus x plus 2 to both sides, right?
Yeah.
So x minus 3 x squared plus 2x. No, not 2x, 1x. I have 2x. Oh, that one was right.
Yeah. I see.
Okay, so let's clean it up. Caw-caw.
Go Munoz!
Get on that.
Okay.
Oh, thanks. Oh, shucks. So we've got a x squared plus ax plus 2a, right? And then in the green part, we're going to get bx squared. That's bx squared plus 3bx plus cx plus 3c. Yeah?
Yep, that's fun.
All right, let's put all our x squares together. So we've got ax squared and bx, right? Is that all the squares?
Yeah.
So that means a plus b x squared. All the x's. That's an x. That's an x. That's an x. Right?
Yeah.
So
A
a
plus
plus b plus c x. And then finally I've got 2a
What happens to the 3 from the BX?
plus 3c. Is that it?
Yeah, wait. What happens to the 3 from the B? From the
Oh,
3BX?
thank you. I just missed it.
I was like, wait a second.
Good looking out. A plus 3b
Plus CX.
plus c. Right?
Yeah.
Okay. So that means system-wise,
And then you skipped one.
a plus b. How much does a plus b equal? 8. And a plus 3b plus c equals 12. And 2a plus 3c equals, there you go. So now you have a 3 by 3 again.
Why can't we just like
Let me close this because I think we're done. We're out of time. Oh, it's over here. I forget which computer I'm on.